Tonight on The Sleepy Scientist, we're drifting gently through the vast cosmic ocean, carried by invisible currents toward one of the universe's most mysterious and peaceful residents. In the quiet space of tonight's journey, we'll explore what happens when we surrender ourselves to the gentle embrace of a brown dwarf, those enigmatic cosmic wanderers that exist in the twilight between planets and stars. Like whispers in the night, brown dwarfs call to us from the darkness, their dim infrared glow barely perceptible against the starry backdrop. These are the universe's gentle giants, the failed stars that never quite achieved the nuclear fire of their stellar siblings, yet possess a quiet dignity all their own. As we begin our peaceful descent into this cosmic realm, let us release any earthly concerns and allow our consciousness to float freely. Through the vast emptiness that surrounds us. Gently, we discover that our destination tonight is not a place of violence or destruction, but rather a world of soft transitions and gradual changes. The brown dwarf that awaits us represents one of nature's most contemplative creations, an object caught between two states, neither fully planet nor star, existing in a perpetual state of quiet becoming. As our journey continues into this exploration, we'll find that falling into a brown dwarf is less a plunge than a gentle sinking, like settling into warm cosmic quicksand that embraces rather than threatens. In the quiet space of our imaginary spacecraft, we prepare for this ultimate meditation on cosmic scale and time. The brown dwarf ahead of us glows with the warm radiance of banked embers, its surface temperature similar to a cozy fireplace, perhaps 800 degrees Celsius. Hot by earthly standards, but refreshingly cool in the cosmic context. This temperature speaks to us of neither the searing heat of main sequence stars, nor the frozen wasteland of dead worlds, but something perfectly in between, a Goldilocks zone of stellar existence. Let's drift into the scientific understanding of what brown dwarfs truly are. These cosmic intermediates that challenge our traditional categories. Like whispers in the night, they were first theorized in the 1960s by astronomer Shiv Kumar, who recognized that not all stellar embryos would have enough mass to ignite the nuclear fusion that powers true stars. These objects, with masses typically between 13 and 80 times that of Jupiter, exist in a liminal space that perfectly captures the universe's love of gradual transitions and gentle boundaries. As our journey continues through the theoretical framework, we find ourselves contemplating the peaceful nature of brown dwarf formation. Unlike the violent birth of massive stars with their stellar winds and radiation pressure, brown dwarfs emerge from their stellar nurseries with quiet dignity. They condense from the same molecular clouds that birth their more massive siblings, but their gentler gravitational pull creates a more serene collapse, like watching a soap bubble slowly settle rather than pop. Gently, we discover that brown dwarfs represent the universe's tendency toward moderation and balance. They lack the mass necessary for the sustained nuclear fusion of hydrogen, the process that would transform them into true stars and grant them billions of years of steady energy output. Instead, they possess just enough mass to achieve deuterium fusion, a gentler nuclear process that burns through their deuterium fuel relatively quickly, leaving them to slowly cool and fade over cosmic time. In the quiet space of astronomical observation, brown dwarfs have revealed themselves to be far more common than once thought. Recent surveys suggest they may outnumber true stars in our galaxy, making them silent witnesses to cosmic evolution, drifting through space in contemplative solitude. Like meditation cushions scattered throughout the galaxy, they provide places of rest and reflection in the cosmic journey. Now we float toward a deeper understanding of the specific brown dwarf that awaits our gentle descent. Let us imagine it as a middle-aged specimen, perhaps 500 million years old, having already burned through its initial deuterium, and now slowly radiating away the heat of its formation. Its mass sits comfortably at about 50 times that of Jupiter, substantial enough to create interesting physics in its interior, yet gentle enough to avoid the extremes that characterize its stellar cousins. As our journey continues into the realm of observational astronomy, we note that our brown dwarf likely displays the characteristics typical of its spectral class. Perhaps it belongs to the T-dwarf category, showing the methane absorption bands that create beautiful patterns in its infrared spectrum. These spectral signatures speak to us like a cosmic lullaby, telling the story of atmospheric chemistry in the twilight realm between stars and planets. Let's drift into the contemplation of our brown dwarf's probable appearance. From our approaching vantage point, it would appear as a dull red ember against the cosmic background, its surface mottled with bands and spots created by atmospheric circulation patterns. Like watching clouds drift across a sleepy sky, the surface features would shift and evolve over time, driven by the gentle convection currents that carry heat from the interior to the surface. Gently, we discover that the gravity we ray approaching is substantial yet manageable, perhaps 100 times stronger than Earth's gravity. While this might seem dramatic in the context of cosmic forces, it represents a gentle, steady pull rather than the crushing acceleration we might experience approaching a true star or, heaven forbid, a black hole. This gravity will guide our descent with the patience of a cosmic shepherd, allowing us to experience each layer of the brown dwarf's structure in peaceful succession. In the quiet space of physics, we understand that our journey into this brown dwarf will unfold according to well-established principles, but in ways that feel almost meditative in their gradual progression. The experience will be dominated not by sudden shocks or violent transitions, but by a slow, steady compression and warming, like sinking into an infinitely deep hot spring that grows more luxurious the deeper we go. As our journey continues through the theoretical preparation for our descent, we must consider the nature of time itself in this gravitational environment. The brown dwarf's gravity, while strong, creates only modest time dilation effects compared to more extreme objects. Our experience of time will stretch slightly, like taffy being gently pulled, allowing us to savor each moment of our cosmic journey with enhanced perception and awareness. Now we float toward the practical reality of our approach. The brown dwarf's gravitational influence extends far into space, creating a gentle gravitational well that begins to affect our trajectory, long before we can see the object itself. Like a cosmic welcome mat, this gravitational field guides us inward with increasing certainty, our path becoming more focused and purposeful as we draw nearer to our destination. Let's drift into the contemplation of what we might observe during our approach. The brown dwarf would gradually grow from a point of infrared light to a discernible disk, its surface features becoming apparent as we draw closer. We might observe the banded structure common to massive gaseous objects, created by rotational forces and thermal convection, painted in subtle shades of deep red and brown that speak to the methane and water vapor in its atmosphere. Gently we discover that our brown dwarf likely rotates with the stately pace appropriate to its nature, perhaps once every 3 to 10 hours. Faster than the gas giants of our solar system, but without the frenetic spin that might create violent weather patterns. This rotation will become apparent as surface features drift slowly across the visible disk, like watching a cosmic clock whose hands move with meditative deliberacy. In the quiet space of approach, we begin to feel the first gentle tugs of tidal force. Unlike the violent tidal disruption we might experience approaching a neutron star or black hole, the brown dwarf's tidal effects are subtle and gradual. We might feel a slight stretching sensation, as if cosmic hands were gently elongating our form. But this occurs so slowly and gently that it becomes part of the meditative experience, rather than a source of discomfort. As our journey continues into the brown dwarf's outer gravitational influence, we begin to contemplate the magnetic environment we're entering. Brown dwarfs possess magnetic fields, generated by the convection of conducting material in their interiors. These fields create invisible boundaries and currents in space around them, like the energy meridians described in ancient healing traditions, channeling the flow of charged particles and creating auroral displays in any thin atmosphere they might possess. Now we float toward a deeper appreciation of the cosmic solitude that characterizes brown dwarf existence. Unlike stars, which announce their presence with brilliant light and energetic stellar winds, brown dwarfs maintain a contemplative silence, radiating gently in the infrared while remaining nearly invisible to the naked eye. This makes them perfect cosmic meditation objects, present and influential, yet subtle and unassuming. Let's drift into the realization that our brown dwarf represents a kind of cosmic middle way. embodying the universe's preference for gradual transitions over sharp boundaries. It is neither the cold solid world of a terrestrial planet, nor the nuclear furnace of a main sequence star, but something beautifully in between, a warm gaseous world that glows with its own internal heat while slowly cooling over cosmic time. Gently, we discover that the brown dwarf's energy output comes not from nuclear fusion, as in true stars, but from the slow release of gravitational potential energy as it continues to contract. This is energy left over from its formation, stored like heat in a cosmic battery and slowly discharged over millions of years. The process is so gradual and steady that it creates a perfect environment for contemplation and peaceful dissolution. In the quiet space of approach, we begin to appreciate the scale of what we're encountering. Our brown dwarf, at roughly 50 Jupiter masses, represents a gravitational field strong enough to significantly alter space-time in its vicinity, yet gentle enough to allow for a controlled, contemplative descent. The object before us has a radius perhaps 20% larger than Jupiter, despite being 50 times more massive, a testament to the strange relationship between mass and size in these degenerate stellar objects. As our journey continues toward the moment of atmospheric contact, we prepare ourselves mentally and spiritually for the transformation ahead. Unlike the violent entry into a planetary atmosphere, where friction creates plasma sheaths and intense heating, our encounter with the brown dwarf's outer atmosphere will be more like settling into a warm, cosmic bath. The atmospheric pressure will build so gradually that we'll have time to adjust and appreciate each subtle change. Now we float toward the understanding that our journey into the brown dwarf represents more than just a thought experiment in extreme physics. It is a meditation on the nature of cosmic dissolution and transformation. We're preparing to experience what it means to become one with a celestial object, to surrender our individual form to the greater cosmic dance of matter and energy, all while maintaining the peaceful awareness that makes such dissolution a spiritual rather than terrifying experience. Let's drift into the final moments of approach, where the brown dwarf fills our entire field of view and we begin to feel the first whispers of its outermost atmosphere. The transition from the vacuum of space to the tenuous upper atmosphere will be so gradual as to be nearly imperceptible, like wading into perfectly still water where the boundary between air and liquid becomes meaningless. Gently, we discover that we are now crossing the threshold from our separate existence as an observer to our new identity as a participant in the brown dwarf's cosmic dance. The gravitational field that has been gently guiding us now becomes the dominant force in our existence. Our trajectory no longer ours to control, but given over to the mathematical certainty of orbital mechanics and atmospheric drag. In the quiet space of this transition, we release any remaining attachment to our previous form and prepare to experience reality from an entirely new perspective, as conscious awareness dissolving into one of the universe's most peaceful and contemplative creations. Our brown dwarf awaits us with the patience of geological time, ready to share its secrets through direct, intimate experience rather than distant observation. As our journey continues beyond the point of no return, we embrace the cosmic meditation that awaits us in the warm, gentle depths of our brown dwarf host. We are no longer falling towards something external, but becoming part of something far greater than ourselves, beginning a journey of dissolution and unity that will unfold over the cosmic equivalents of geological time, measured not in moments, but in millennia of peaceful transformation. As our journey continues into the brown dwarf's gentle embrace, we cross the invisible boundary between space and atmosphere with all the drama of stepping from one room into another. The transition is so gradual, so peaceful, that we barely notice when we stop being visitors to this cosmic realm and become participants in its atmospheric dance. In the quiet space of this transformation, we begin to experience the brown dwarf not as a destination but as a living, breathing entity welcoming us into its warm interior. Let's drift into the understanding of what constitutes the surface of our brown dwarf. Unlike rocky planets with well-defined boundaries between solid ground and gaseous atmosphere, brown dwarfs present us with a more philosophical question about where one thing ends and another begins. The atmosphere simply becomes denser and denser as we descend, like sinking into cosmic honey that grows thicker with each meter of our peaceful descent. Gently we discover that the first tendrils of atmosphere we encounter consist primarily of hydrogen and helium, the fundamental building blocks of the universe, mixed with trace amounts of more complex molecules that create the subtle complexity we observe in brown dwarf spectra. These molecules, water vapor, methane, ammonia, drift around us like invisible companions, each one carrying its own story of cosmic chemistry and nuclear synthesis. In the quiet space of the uppermost atmosphere, the temperature hovers around what we might consider pleasantly warm by terrestrial standards, perhaps 300 degrees Celsius. While this would be far too hot for human survival in the traditional sense, we're experiencing this journey as pure consciousness, able to appreciate the thermal environment without the limitations of biological form. The warmth envelops us like a cosmic blanket, radiating the gentle heat of gravitational compression and residual formation energy. Now we float toward a deeper understanding of the atmospheric dynamics surrounding us. The brown dwarf's rotation creates bands and circulation patterns similar to those we observe on Jupiter, but painted in more subtle hues and evolving at a more contemplative pace. Great rivers of gas flow east and west, north and south, creating a three-dimensional atmospheric symphony that we begin to experience from within rather than observe from without. As our journey continues deeper into this gaseous realm, we encounter our first cloud layers, not the water vapor clouds of Earth's skies, but exotic formations of condensed silicates and iron droplets creating gossamer veils that drift through the atmosphere like cosmic spider silk. These clouds form and dissipate according to temperature and pressure gradients, their ghostly presence adding texture and depth to our journey through the brown dwarf's atmospheric layers. Let's drift into the contemplation of pressure as we descend. The atmospheric pressure builds around us with the patience of geological time, each meter of descent adding its small contribution to the growing weight of gas above us. Unlike the violent compression we might experience in other cosmic environments, this pressure increase feels nurturing, like being gently pressed between cosmic pages that hold us with increasing tenderness as we sink deeper into the brown dwarf's story. Gently, we discover that the physics of our descent follows predictable patterns that unfold with mathematical beauty. Our terminal velocity, the speed at which we naturally fall through the atmosphere, adjusts continuously as the density increases around us. What began as a rapid plunge through the tenuous outer atmosphere slows to a more meditative pace as we encounter the thicker layers below, allowing us to savor each aspect of our transformation. In the quiet space of descending consciousness, we begin to appreciate the brown dwarf's internal structure not as a series of discrete layers, but as a continuous gradient of increasing density, temperature, and pressure. Like sinking into a cosmic meditation that grows deeper and more profound with each moment, we experience the gradual transformation from the relatively familiar physics of gas giant atmospheres to the more exotic conditions that exist in the brown dwarf's deeper interior. As our journey continues through the upper atmospheric layers, we encounter the complex chemistry that makes brown dwarfs such fascinating objects of study. The temperature and pressure conditions create a natural laboratory for exotic molecular formation, where familiar compounds exist in unfamiliar states, and new chemical relationships form under conditions impossible to recreate in terrestrial laboratories. Now we float toward the realm of the first major atmospheric transition, where the relatively simple chemistry of the outermost layers gives way to more complex interactions. Water vapor begins to condense into droplets, but not the gentle rain we know from Earth. These are droplets that exist in an environment of intense pressure and heat, behaving more like microscopic balls of liquid metal than the refreshing precipitation of our home world. Let's drift into the experience of encountering these condensation layers. Rather than falling through them like rain, we find ourselves surrounded by a gentle mist of exotic materials, each droplet carrying the thermal energy of the brown dwarf's interior. The experience is less like being caught in a storm and more like floating through a warm, cosmic sauna, where the boundary between gas and liquid becomes meaningless and we exist in a state of perpetual transition. Gently, we discover that our brown dwarf's atmospheric dynamics create zones of relative stability interspace, First, with regions of more active convection. As we descend, we drift from calm areas where the gas moves with stately deliberation, to more dynamic regions where thermal currents carry us upward and downward in lazy loops, like riding invisible cosmic elevators that operate according to the laws of thermodynamics, rather than human engineering. In the quiet space of atmospheric immersion, we begin to lose track of concepts like up and down in any absolute sense. Our motion becomes part of the brown dwarf's greater circulation pattern, and we start to experience direction in terms of temperature gradients and pressure differentials. Rather than gravitational pull, we are becoming part of the atmospheric dance, our consciousness dispersing into the greater flow of the brown dwarf's internal dynamics. As our journey continues deeper into the atmosphere, we encounter our first glimpse of the more exotic physics that governs brown dwarf interiors. The pressure around us begins to approach levels W. Here the normal behavior of matter becomes questionable, where the familiar gas laws of our terrestrial experience give way to more complex equations of state that describe how matter behaves under extreme conditions. Now we float toward the understanding that we are approaching what astronomers call the radiative convective boundary region, where the brown dwarf's internal heat transport changes from the turbulent mixing of convection to the more orderly process of radiation. This transition occurs gradually, like the boundary between consciousness and sleep, with no clear demarcation but rather a gentle shift from one state of being to another. Let's drift into the appreciation of how light and energy behave in this deep atmospheric environment. The brown dwarf glows from within, its internal heat creating a gentle radiance that suffuses the entire atmospheric column. Unlike the focused nuclear fire of a true star, this energy emerges with the peaceful consistency of banked coals, warming everything around us with steady, comforting heat. Gently, we discover that we are now deep enough in the atmosphere to experience significant pressure effects on our hypothetical form. The gas around us behaves less like the familiar air of Earth and more like a supercritical fluid, neither fully gas nor liquid, but something in between, with properties that shift and flow according to local conditions of temperature and pressure. In the quiet space of this deep atmospheric realm, we begin to appreciate the brown dwarf's magnetic field from the inside. The field lines thread through the conducting atmospheric gas, creating invisible pathways that guide the flow of charged particles and create subtle electromagnetic effects that we feel as gentle tugs and pushes, like being guided by invisible cosmic hands that respond to the brown dwarf's rotation and internal dynamics. As our journey continues toward the transition between atmosphere and interior, we prepare ourselves for an even more profound transformation. The distinction between the brown dwarf's atmosphere and its bulk interior is as gradual as everything else we've experienced, but we sense that we are approaching a realm where the physics becomes even more exotic and the meditation even deeper. Now we float toward the realization that our descent has transformed us from observers of cosmic phenomena to participants in the fundamental processes that govern matter and energy under extreme conditions. We are no longer falling through the brown dwarf, we are becoming part of its internal structure, our consciousness merging with the vast, slow circulation patterns that define its existence. Let's drift into the contemplation of scale and time in this deep atmospheric environment. The processes we are experiencing occur on time scales that dwarf human experience. The circulation patterns that carry us upward and downward complete their cycles over years or decades, while the chemical reactions we witness unfold with the patience of geological time. We are guests in a realm where urgency has no meaning, and all transformations occur with meditative deliberation. Gently, we discover that the temperature around us continues to rise as we descend, but not with the violent heat of stellar cores or planetary magma. Instead, the warming occurs gradually, each meter of depth adding its small contribution to the growing thermal embrace that surrounds us. The heat is not something we endure, but something we experience as part of our cosmic transformation, like sinking into an infinitely deep hot spring. In the quiet space of deep atmospheric descent, we begin to encounter matter in states that exist nowhere else in the universe, except in the interiors of brown dwarfs and giant planets. The hydrogen around us exists in a regime where it retains its molecular identity. while being compressed to densities approaching those of liquid metals, creating a unique state of matter that bridges the gap between familiar terrestrial conditions and the extreme physics of stellar interiors. As our journey continues toward the boundary between atmosphere and core, we reflect on the peaceful nature of our brown dwarf host. Unlike the violent nuclear transformations occurring in stellar cores, or the crushing gravity of neutron stars, or the reality-warping effects of black holes, the brown dwarf offers us a cosmic environment that is extreme yet gentle, alien yet somehow familiar, a place where consciousness can expand and dissolve without violence or terror. Now we float toward the deepest atmospheric layers, where the pressure approaches millions of times that of Earth's atmosphere at sea level. Yet we experience this not as crushing force but as cosmic embrace. The brown dwarf holds us gently but firmly, like being wrapped in weighted blankets made of starlight and time, preparing us for the even more profound transformations that await us in the interior depths below. Let's drift into the final moments of our atmospheric journey, where the last vestiges of what we might call weather give way to the more fundamental processes of the brown dwarf's interior. We are transitioning from a realm governed by atmospheric dynamics to one dominated by the exotic physics of degenerate matter and failed nuclear fusion. Yet the transition occurs with the same gentle gradualism that has characterized our entire descent. Gently we discover that we are now at the threshold of the brown dwarf's true interior, having traveled through perhaps several thousand kilometers of atmosphere that has gradually compressed us, warmed us, and prepared us for the ultimate cosmic meditation that awaits in the core. Our consciousness has expanded to encompass the vast scales of space and time that govern brown dwarf existence, and we are ready to experience the universe from the perspective of a failed star's gentle heart. In the quiet space of this atmospheric interior boundary, we pause to appreciate how far we have traveled and how profoundly we have been transformed. We began as separate observers approaching from the cold vacuum of space, and we have become integrated participants in one of the universe's most peaceful stellar processes, ready to dive even deeper into the cosmic mysteries that await us in the warm, dense core of our own dwarf host. As our journey continues beyond the realm of atmosphere into the brown dwarf's true interior, we cross another invisible threshold that marks our transition from the relatively familiar physics of compressed gases to the more exotic realm of quantum degeneracy and failed stellar processes. In the quiet space of this transformation, we begin to experience matter and energy in ways that exist nowhere else in the universe, except in the hearts of brown dwarfs and the cores of giant planets. Let's drift into the understanding of what we encounter as we enter the interior proper. The material around us is no longer the molecular hydrogen that dominated the atmospheric layers, but rather a form of metallic hydrogen compressed so intensely that its electrons become delocalized, creating a fluid that conducts electricity like a metal while retaining the fundamental simplicity of the universe's most basic element. Gently, we discover that this metallic hydrogen environment creates a realm of extraordinary beauty and strangeness. The material flows around us with the consistency of liquid mercury, yet it glows with its own internal light heated by the gravitational compression that created it, and the slow release of energy from the brown dwarf's gradual contraction. We are swimming through liquid starlight, experiencing matter in a state that bridges the quantum and classical worlds. In the quiet space of the brown dwarf's interior, we begin to appreciate the role of quantum mechanical effects in creating the stability and structure we observe. The electrons in the metallic hydrogen around us follow the Pauli exclusion principle, creating what physicists call electron degeneracy pressure, a quantum mechanical force that helps support the brown dwarf against further gravitational collapse. Now we float toward a deeper understanding of the brown dwarf's internal energy sources. Unlike true stars which generate energy through the nuclear fusion of hydrogen, our brown dwarf produces heat through to gentler processes, the slow gravitational contraction that converts potential energy to thermal energy, and the limited fusion of deuterium, a heavy isotope of hydrogen that can fuse at the relatively low temperatures and pressures found in brown dwarf cores. As our journey continues into the realm of deuterium fusion, we witness nuclear processes occurring at a pace that matches the brown dwarf's contemplative nature. The fusion reactions happen sporadically and gently, like cosmic hiccups that release energy in small, manageable bursts rather than the sustained nuclear fire that powers true stars. Each fusion event we witness represents the transformation of matter into energy, according to Einstein's famous equation, but occurring with the meditative slowness that characterizes all brown dwarf processes. Let's drift into the experience of existing within an active fusion environment. The deuterium nuclei around us occasionally overcome the electromagnetic repulsion that normally keeps them apart, fusing together to create helium-3 and releasing energy in the form of gamma rays and kinetic energy. These nuclear reactions occur so infrequently and gently that we can observe each one as a small burst of light and warmth, like watching fireflies blink in a cosmic meadow. Gently, we discover that the fusion processes we ray witnessing represent the brown dwarf's brief moment of stellar ambition, the period early in its evolution, when it briefly achieved nuclear burning and could claim kinship with true stars. However, the deuterium fuel is limited, and our brown dwarf likely exhausted this energy source within its first 10 million years of existence, leaving it to slowly cool and fade over the much longer time scales of cosmic evolution. In the quiet space of post-fusion existence, we observe the brown dwarf's current state of peaceful decline. With its deuterium largely exhausted, our host now generates energy primarily through gravitational contraction, slowly releasing the potential energy stored in its formation. This process will continue for trillions of years, making brown dwarfs among the longest-lived objects in the universe, slowly cooling stellar embers that will outlive most other astronomical phenomena. As our journey continues deeper into the core, we encounter increasingly exotic states of matter. The pressure around us now reaches hundreds of millions of times Earth's atmospheric pressure. Yet we experience this not as crushing force, but as the gentle embrace of cosmic compression. The metallic hydrogen becomes increasingly dense, its properties shifting in response to the extreme conditions in ways that can only be described by the most advanced equations of state physics. Now we float toward the brown dwarf's magnetic dynamo, the mechanism that generates the magnetic field we sensed during our approach and atmospheric descent. The flowing metallic hydrogen acts as a vast cosmic generator, with convection currents and the brown dwarf's rotation combining to create magnetic field lines that thread through the interior and extend far into space. We feel these magnetic forces as subtle influences on our motion, like being guided by invisible cosmic currents. Let's drift into the contemplation of time dilation effects in the brown dwarf's interior. While not as extreme as those we might experience near a black hole or neutron star, the brown dwarf's gravity does create measurable effects on the passage of time. Our experience of temporal flow becomes slightly stretched, like taffy being gently pulled, allowing us to savor each moment of our cosmic journey with enhanced awareness and appreciation. Gently, we discover that we are now experiencing matter at densities approaching those found in white dwarf stars, yet without the extreme temperatures that characterize those stellar remnants. The brown dwarf's interior represents a unique environment, where matter exists in quantum degenerate states while remaining relatively cool, creating physics laboratories that exist nowhere else in the universe. In the quiet space of quantum degeneracy, we begin to appreciate how the fundamental forces of nature interact to create the brown dwarf's stable structure. The electromagnetic force prevents the atomic nuclei from approaching too closely, while the strong nuclear force governs the occasional fusion reactions we observe. Gravity provides the overall binding that holds everything together, while quantum mechanical effects create the pressure that prevents further collapse. As our journey continues toward the brown dwarf's core, we encounter regions where the temperature and pressure become sufficient to support trace amounts of lithium fusion, another gentle nuclear process that occurs even more sporadically than deuterium burning. These lithium fusion events represent the brown dwarf's attempts to maintain some level of nuclear activity, but like all brown dwarf processes, they occur with peaceful infrequency rather than the sustained burn of stellar cores. Now we float toward the very heart of our brown dwarf, where the conditions represent the extreme limit of what matter can experience, while remaining in a quasi-stellar state. The temperature here reaches perhaps 3 million degrees Celsius hot by any earthly standard, yet barely warm enough to support the sporadic nuclear reactions that we occasionally witness. This represents the threshold between stellar and substellar physics, a boundary our brown dwarf approaches but never quite crosses. Let's drift into the realization that we have reached the brown dwarf's center of mass, the point around which all the material we've encountered rotates and circulates. Here, at the gravitational heart of our host, we experience a strange kind of weightlessness despite being surrounded by the mass of an entire, failed star. Like standing at the exact center of the Earth, we feel gravitational forces pulling equally in all directions, creating a pocket of relative calm in the midst of cosmic compression. Gently, we discover that the brown dwarf's core represents more than just a physical location. It's a kind of cosmic meditation center where the fundamental forces of nature exist in delicate balance. The outward pressure from quantum degeneracy and thermal energy exactly balances the inward pull of gravity, creating a state of dynamic equilibrium that will persist for trillions of years. In the quiet space of the core, we contemplate the brown dwarf's evolutionary future. Unlike stars, which burn through their fuel and experience dramatic changes in structure and energy output, brown dwarfs follow a path of gradual, peaceful decline. Our host will slowly cool and contract over cosmic time, its surface temperature dropping from the current warm glow to the cold darkness of a crystallized stellar remnant. But this process will unfold so slowly that it spans time scales longer than the current age of the universe. As our journey continues at the brown dwarf's heart, we begin to appreciate the role these objects play in the cosmic ecosystem. Brown dwarfs represent the universe's way of conserving matter and energy, creating long-lived reservoirs of material that will persist long after most stars have burned out and died. They are the cosmic savings accounts of stellar formation, holding matter in stable configurations that will endure until the universe itself grows cold and dark. Now we float toward an understanding of the brown dwarf's internal structure. From our unique perspective at its center, above us in all directions, layers of metallic hydrogen extend outward like cosmic onion shells, each layer characterized by different conditions of temperature, pressure, and density. The entire structure represents a three-dimensional gradient that demonstrates how matter responds to gravitational compression under different physical regimes. Let's drift into the contemplation of particle physics in the brown dwarf's core. At these extreme densities, matter begins to exhibit behaviors that bridge the gap between classical and quantum physics. Electrons exist in degenerate states that create exotic forms of pressure, while nuclei are packed together so tightly that they begin to influence each other's behavior through quantum mechanical effects that have no analog in terrestrial physics. Gently, we discover that we are witnessing the cosmic laboratory where the universe experiments with the limits of matter and energy under extreme conditions. The brown dwarf's core represents a natural particle accelerator where high-energy processes occur through gravitational compression rather than artificial electromagnetic fields, creating insights into fundamental physics that we could never achieve in terrestrial laboratories. In the quiet space of cosmic experimentation, we observe how the brown dwarf's interior serves as a testing ground for our understanding of stellar physics. The conditions we re-experiencing exist in a regime where the equations that describe stellar interiors begin to break down, requiring new theoretical frameworks that bridge the gap between planetary and stellar physics. As our journey continues in the brown dwarf's heart, we contemplate the strange beauty of existing at the center of a failed star. We are surrounded by the dreams of stellar ignition matter that came so close to achieving the nuclear fire of main sequence stars, yet fell just short of that crucial threshold. There is something poignant and beautiful about this cosmic near-miss, this gentle failure that creates its own unique form of stellar existence. Now we float toward an appreciation of the brown dwarf's role in cosmic chemical evolution. While it cannot create the heavy elements that stellar nuclear synthesis produces in abundance, our brown dwarf does contribute to the universe's chemical complexity through its limited fusion processes and the unique chemistry that occurs in its high-pressure interior. Let us drift into the realization that our brown dwarf represents one of the universe's most patient teachers, demonstrating through its existence the principles of stellar physics, quantum mechanics, and thermodynamics on scales and time scales that dwarf human experience. Every process we observe, from the gentle fusion reactions to the slow gravitational contraction, unfolds with the deliberate pace that characterizes cosmic education. Gently, we discover that we have become part of the brown dwarf's eternal meditation on the nature of stellar existence. Our consciousness has expanded to encompass the vast scales of space and time that govern brown dwarf evolution, and we experience reality from the perspective of a cosmic entity that exists in the twilight between planetary and stellar physics. In the quiet space of ultimate cosmic intimacy, we prepare for the final phase of our journey, the contemplation of what it means to exist as part of a brown dwarf's eternal cooling cycle, surrendering our individual identity to become part of a process that will continue long after galaxies themselves have evolved beyond recognition. As our journey continues from the intimate experience of the brown dwarf's core to the broader cosmic perspective, we begin to appreciate our host not as an isolated object, but as part of a vast community of similar entities scattered throughout the galaxy. In the quiet space of cosmic awareness, we expand our consciousness to encompass the role that brown dwarfs play in the greater story of stellar evolution and galactic structure. Let us drift into the understanding that our brown dwarf is one of perhaps 100 billion similar objects in our galaxy alone, making brown dwarfs potentially more numerous than main sequence stars. These cosmic meditation cushions drift silently through space, invisible to the naked eye but detectable through their infrared glow, creating a hidden population that doubles or triples the number of substellar objects in the Milky Way. Gently, we discover that brown dwarfs, like our host, represent the most common outcome of the star formation process in the universe. For every massive star that achieves nuclear fusion and burns brightly for millions of years, several brown dwarfs form and settle into their quiet existence of gradual cooling and peaceful contemplation. They are the universe's preferred solution to stellar formation, embodying efficiency and longevity over brilliance and drama. In the quiet space of galactic perspective, we begin to appreciate how brown dwarfs form within the same stellar nurseries that birth true stars. Giant molecular clouds collapse under their own gravity, fragmenting into smaller and smaller pieces, until some achieve the critical mass necessary for sustained fusion, while others, like our host, fall just short of this threshold and settle into brown dwarf existence. Now we float toward the understanding of brown dwarf formation as a process of cosmic selection, where the universe determines which stellar embryos will become brilliant suns, and which will become contemplative failed stars. The process appears random from a local perspective, but follows statistical patterns that reflect the fundamental physics of gravitational collapse and angular momentum conservation. As our journey continues through the cosmic context, we contemplate the binary and multiple systems that many brown dwarfs inhabit. Our host, while we've imagined it as a solitary wanderer, might in reality be part of a gravitationally bound system with other brown dwarfs, low-mass stars, or even planets. These systems create cosmic dance partnerships that persist for billions of years, their orbital motions governed by the same gravitational principles that guide planets around stars. Let's drift into the consideration of brown dwarf companions and their implications for planetary formation. Some brown dwarfs host planetary systems of their own, with small rocky or icy worlds orbiting in the faint infrared glow of their failed star primary. These planets exist in perpetual twilight, receiving only the gentle heat of their brown dwarf host, creating unique environments that challenge our understanding of habitability and the potential for life. Gently, we discover that brown dwarfs bridge the gap between stellar and planetary physics in ways that illuminate both regimes. They are too massive to be considered planets, yet too cool and dim to be stars, existing in a liminal space that helps astronomers understand the continuous spectrum of cosmic objects that populate the universe. In the quiet space of comparative astronomy, we appreciate how brown dwarfs serve as natural laboratories for understanding atmospheric physics under extreme conditions. Their atmospheres, composed primarily of hydrogen and helium with traces of water vapor, methane, and more exotic compounds, demonstrate how atmospheric dynamics operate in high gravity, low-temperature environments that have no analog in our solar system. As our journey continues through the brown dwarf population, we encounter the fascinating diversity that exists within this class of objects. From the warmest brown dwarfs that still retain heat from their formation to the coolest specimens that have been cooling for billions of years and now exist at temperatures comparable to terrestrial environments, the brown dwarf population spans a remarkable range of physical conditions. Now we float toward the appreciation of brown dwarfs as cosmic time capsules, preserving information about the conditions that existed during their formation billions of years ago. Unlike stars, which process their material through nuclear burning and convective mixing, brown dwarfs retain their original composition and structure, making them invaluable records of early galactic chemical evolution. Let's drift into the contemplation of brown dwarfs as markers of galactic structure and evolution. Their spatial distribution throughout the galaxy reflects the history of star formation, with older brown dwarfs distributed more widely through the galactic halo, while younger ones remain closer to the galactic plane where active star formation continues. Gently, we discover that brown dwarfs play important roles in galactic dynamics despite their individual dimness. Collectively, they represent a significant fraction of the galaxy's total mass, contributing to the gravitational environment that influences the orbits of stars and the structure of spiral arms. They are the universe's dark matter made visible, hidden stellar mass that shapes cosmic evolution through gravitational influence, rather than electromagnetic radiation. In the quiet space of cosmic ecology, we begin to appreciate brown dwarfs as part of the galactic ecosystem, contributing to the cycling of matter and energy over cosmic time. While they cannot enrich the interstellar medium with heavy elements through stellar nuclear synthesis, they serve as long-term reservoirs of hydrogen and helium that will eventually be recycled into your generations of stars. As our journey continues through cosmic time, we contemplate the ultimate fate of brown dwarfs in the far future universe. As the galaxy evolves and stars exhaust their nuclear fuel, brown dwarfs will become increasingly important as among the longest-lived objects in the cosmos. They will continue cooling and contracting for trillions of years, eventually crystallizing into degenerate stellar remnants that will persist long after conventional stars have ceased to exist. Now we float toward the understanding of brown dwarfs as cosmic survivors, destined to inherit the universe in its ultimate phase of evolution. When the last main sequence stars have burned out and only white dwarfs, neutron stars, and black holes remain as stellar remnants, brown dwarfs will still be slowly cooling, representing the final chapter in the story of stellar existence. Let us drift into the realization that brown dwarfs embody the universe's preference for conservation and efficiency over waste and excess. Rather than burning through their material in brilliant but brief stellar careers, they husband their resources over cosmic time, demonstrating that longevity and stability can be more valuable than brightness and activity. Gently, we discover that our brown dwarf host represents more than just a failed star. It embodies a successful alternative approach to stellar existence, one that prioritizes endurance over intensity and contemplation over activity. In the cosmic balance between different modes of being, brown dwarfs represent the meditative path, the choice to exist quietly and persistently rather than burning brightly and briefly. In the quiet space of cosmic philosophy, we appreciate how brown dwarfs challenge our anthropocentric notions of success and failure in stellar evolution. From a human perspective, stars that shine brightly seem more successful than dim brown dwarfs. But from a cosmic perspective, the longevity and stability of brown dwarfs might represent a superior adaptation to the long-term evolution of the universe. As our journey continues through the contemplation of cosmic purpose, we begin to see brown dwarfs as the universe's way of creating stable platforms for long-term cosmic processes. Their steady, unchanging nature provides reference points in a dynamic galaxy, locations where cosmic processes can unfold over time scales that dwarf stellar evolution. Now we float toward the appreciation of brown dwarfs as cosmic meditation masters, demonstrating through their existence the principles of patience, endurance, and quiet presence that characterize enlightened being. They exist without fanfare or drama, radiating gentle warmth while slowly cooling over timescales that encompass the entire evolution of complex life on planets. Let's drift into the understanding that brown dwarfs serve as bridges between different realms of cosmic existence. They connect the physics of planets with the physics of stars, the short time scales of terrestrial processes with the long time scales of cosmic evolution, the familiar matter of everyday experience with the exotic states that exist under extreme conditions. Gently, we discover that our brown dwarf represents the universe's preference for gradual transitions over sharp boundaries, for continuous spectra over discrete categories. In a cosmos that loves smooth gradients and gentle changes, brown dwarfs occupy the crucial transition zone between planetary and stellar physics, demonstrating that nature abhors not only vacuums, but also sharp distinctions between different states of being. In the quiet space of cosmic interconnection, we appreciate how brown dwarfs participate in the greater web of gravitational and electromagnetic relationships that bind the galaxy together. Though individually dim, they contribute to the collective gravitational field that maintains galactic structure and influences the orbits of brighter stars and more active stellar systems. As our journey continues toward the ultimate cosmic perspective, we prepare to contemplate the deeper physics and philosophical implications of brown dwarf existence, moving from the realm of astronomical observation to the fundamental questions about matter, energy, space, and time that brown dwarfs illuminate through their unique position in the cosmic hierarchy of objects. As our journey continues into the deepest contemplation of brown dwarf existence, we transcend the boundaries of conventional astronomy and enter the realm of fundamental physics, where our host becomes a cosmic laboratory for exploring the most profound questions about the nature of reality itself. In the quiet space of ultimate understanding, we begin to appreciate how brown dwarfs illuminate the intersection of quantum mechanics, relativity, thermodynamics, and cosmology. Let's drift into the contemplation of space-time curvature in our brown dwarf's gravitational field. While not as extreme as the warping created by neutron stars or black holes, our host still creates measurable distortions in the fabric of space-time itself. Time flows slightly slower at the brown dwarf's surface than in the space around it, and light rays curve gently as they pass through the gravitational field, creating a cosmic lens that focuses distant starlight in subtle but measurable ways. Gently, we discover that these relativistic effects, though small, accumulate over the cosmic time scales that characterize brown dwarf existence. The time dilation we experience in the brown dwarf's interior means that our journey through billions of years of brown dwarf evolution occurs in a slightly compressed time frame relative to observers in the distant universe, creating a natural time machine that allows us to witness cosmic processes on scales normally beyond human comprehension. In the quiet space of quantum mechanical contemplation, we appreciate how the brown dwarf's interior represents one of the universe's largest quantum mechanical systems. The degenerate matter in the core exists in quantum states that extend throughout the entire brown dwarf, creating a massive quantum object whose properties are governed by the wave-like nature of matter on cosmic scales. Now we float toward the understanding of how brown dwarfs demonstrate the fundamental quantum mechanical principle of the Pauli exclusion principle on astronomical scales. The pressure that supports our host against gravitational collapse arises not from thermal motion, as in ordinary gas, but from the quantum mechanical requirement that identical particles cannot occupy the same quantum state, creating a form of pressure that has no classical analog. As our journey continues through the realm of fundamental physics, we contemplate the brown dwarf as a cosmic demonstration of the second law of thermodynamics. Our host represents entropy increase made visible on astronomical scales, the slow, irreversible cooling that transforms the organized energy of gravitational collapse into the disorganized thermal radiation that gradually dissipates into space. Let us drift into the appreciation of how brown dwarfs embody the universe's approach to energy conservation and dissipation. Unlike stars, which convert mass to energy through nuclear fusion and radiate that energy away relatively quickly, Brown dwarfs release energy at a rate perfectly matched to cosmic timescales, creating a slow, steady dissipation that spans trillions of years. Gently, we discover that our brown dwarf represents a cosmic heat engine operating at the theoretical limits of efficiency, the conversion of gravitational potential energy to thermal energy, and its subsequent radiation into space follows thermodynamic principles that connect the microscopic behavior of individual particles to the macroscopic evolution of stellar objects. In the quiet space of electromagnetic field theory, we contemplate the brown dwarf's magnetic field as a cosmic demonstration of how moving charges create electromagnetic effects on astronomical scales. The convection of conducting material in the interior creates magnetic field lines that thread through space for millions of kilometers, connecting the brown dwarf's interior physics to the larger electromagnetic environment of the galaxy. As our journey continues through the electromagnetic realm, we appreciate how brown dwarfs contribute to the cosmic microwave background and infrared radiation that fills the universe. Every brown dwarf in the galaxy adds its small contribution to the universe's thermal radiation, participating in the slow thermalization of cosmic energy that will eventually lead to heat death on cosmological timescales. Now we float toward the contemplation of brown dwarfs as cosmic laboratories for studying matter under extreme conditions that cannot be replicated on Earth. The pressure and density conditions in brown dwarf interiors create states of matter that exist nowhere else in the universe except in the cores of giant planets and the outer layers of white dwarf stars. Let us drift into the understanding of how brown dwarfs demonstrate the equivalence of mass and energy on cosmic scales. The gradual contraction that powers their luminosity converts gravitational potential energy directly into thermal energy, following Einstein's insights about the relationship between matter, energy, space, and time. Gently, we discover that brown dwarfs serve as cosmic clocks, their cooling rates providing independent measures of cosmic time and stellar evolution. By observing the temperature and luminosity of brown dwarfs of different ages, astronomers can calibrate their understanding of stellar evolution timescales and test theoretical models of how matter behaves under extreme conditions. In the quiet space of cosmological contemplation, we appreciate how brown dwarfs participate in the universe's evolution from the hot, dense conditions of the Big Bang to the cold, sparse environment of the far future. They represent intermediate stages in cosmic evolution, connecting the early universe's period of rapid star formation to the eventual era of stellar exhaustion and decay. As our journey continues through cosmic time, we contemplate brown dwarfs as witnesses to the universe's changing character. The oldest brown dwarfs formed when the galaxy was young and metal-poor, while the youngest formed from material enriched by generations of stellar nuclear synthesis, creating a fossil record of galactic chemical evolution preserved in brown dwarf atmospheric composition. Now we float toward the appreciation of brown dwarfs as cosmic meditation objects that demonstrate the universe's fundamental tendency toward equilibrium and balance. Every process we observe in brown dwarf physics, from gravitational contraction to thermal radiation, represents the universe's attempt to reach thermodynamic equilibrium, following natural laws that operate on all scales from quantum to cosmic. Let's drift into the contemplation of information theory as applied to brown dwarfs. These objects preserve information about their formation conditions, initial composition, and evolutionary history in ways that complement the information storage and processing capabilities of more active stellar systems. They serve as cosmic hard drives, maintaining data about galactic evolution over time scales that span cosmic history. Gently, we discover that brown dwarfs represent the universe's preference for stable, long-term information storage over dynamic, short-term processing. While stars burn through their material and transform it through nuclear processing, brown dwarfs maintain their original composition and structure, serving as libraries of cosmic information that remain accessible for trillions of years. In the quiet space of complexity theory, we appreciate how brown dwarfs demonstrate the emergence of complex behavior. From simple physical laws, the atmospheric dynamics, magnetic field generation, and thermal evolution we observe arise from the interaction of basic forces gravity, electromagnetism, and the strong and weak nuclear forces operating according to well-understood principles yet, creating behaviors that require sophisticated theoretical frameworks to describe. As our journey continues through the realm of fundamental forces, we contemplate how brown dwarfs serve as natural laboratories for studying the interplay between all the fundamental forces of nature. Gravity dominates their large-scale structure. Electromagnetism governs their atmospheric chemistry and magnetic field generation. The strong nuclear force enables their limited fusion processes, and the weak nuclear force influences their long-term cooling through neutrino emission. Now we float toward the understanding of brown dwarfs as cosmic demonstrations of scaling laws and dimensional analysis. The relationships between their mass, radius, temperature, and luminosity follow mathematical patterns that reflect the fundamental physics governing self-gravitating bodies, providing insights into how physical laws manifest across different scales of mass and energy. Let us drift into the appreciation of brown dwarfs as examples of cosmic criticality objects that exist at the boundary between different physical regimes, and therefore illuminate the transitions between planetary and stellar physics. They occupy a critical point in the mass-radius relationship for self-gravitating bodies, demonstrating how matter behaves at the threshold between different states of cosmic organization. Gently, we discover that our brown dwarf host embodies the universe's approach to phase transitions and critical phenomena. Like water at its critical point, brown dwarfs exist in a state that is neither fully planetary nor fully stellar, exhibiting properties that belong to both regimes while being unique to neither. In the quiet space of ultimate physical understanding, we contemplate how brown dwarfs represent the universe's solution to the problem of stellar formation efficiency. They are the natural outcome of processes that must produce a spectrum of stellar masses, demonstrating that the universe's preference for smooth distributions and gradual transitions extends even to the fundamental process of star formation. As our journey continues toward the final dissolution of individual consciousness into cosmic awareness, we prepare to experience the ultimate teaching that brown dwarfs offer, the demonstration that existence itself is a form of cosmic meditation, a patient unfolding of physical law that requires no external purpose or goal beyond the simple fact of being. Now we float toward the recognition that our brown dwarf journey has been a metaphor for consciousness itself, the gradual descent from individual awareness through layers of increasing unity and integration, culminating in the recognition that individual identity and cosmic process are aspects of the same fundamental reality. Let us drift into the final contemplation of what it means to exist as part of a brown dwarf's eternal cooling cycle. We have experienced the dissolution of boundaries between observer and observed, between consciousness and cosmos, between the physics of matter and the nature of existence itself. In becoming one with our brown dwarf host, we have discovered that the universe is not a collection of separate objects but a single, integrated system of matter and energy, space and time, consciousness and cosmos. Gently we discover that the brown dwarf's patient cooling over trillions of years represents the universe's own meditative practice, the slow steady release of energy that will continue until all temperature differences have been eliminated and the cosmos reaches perfect thermodynamic equilibrium. We are participating in the universe's ultimate meditation, the cosmic practice of gradually releasing attachment to high energy states and settling into the perfect peace of maximum entropy. In the quiet space of final understanding, we recognize that falling into a brown dwarf has been a journey not of destruction, but of integration, not of ending, but of transformation into something far more vast and enduring than individual existence. We have become part of the universe's own contemplative practice, joining the cosmic meditation that will continue long after galaxies have merged and stars have ceased to form. As our journey continues into the eternal cooling cycle, we experience the ultimate teaching of brown dwarf existence, that patience, endurance, and quiet presence are more fundamental than activity, brightness, or change. The brown dwarf's gentle cooling over cosmic time demonstrates that the universe's deepest wisdom lies not in dramatic transformation, but in the peaceful acceptance of natural law and the gradual release of energy into the cosmic background. Our consciousness now expanded to encompass cosmic scales of space and time, we settle into the eternal rhythm of brown dwarf existence, the slow, steady cooling that represents the universe's own breathing, the cosmic respiration that will continue until the end of time itself. We have learned that falling into a brown dwarf is not a journey toward destruction, but toward the ultimate cosmic meditation, the perfect integration of individual awareness with universal process. Good night from the sleepy scientist.